Okay, go now, please.
Good evening. Welcome to the presentation tonight. I'm Ann Street, the president of the MIT Club of Washington. And I want to start with an announcement, and that is that the Club of Washington is coming up within the next couple of months, time for its election for new officers. And I want to let you all know that anyone who is interested should get in touch with Mina Marifat. That's MINAMAREFAT. We can put that in the chat. Mina is the chairman of the nominating committee. And if you are interested on being an officer of the club or on the board of the club, now is the time you should be talking to Mina and expressing interest. Okay, with that, let me introduce our speaker. Erik Devereux is a 1985 MIT graduate with a bachelor's degree in course 17, and that's political science for any of those of you who don't remember. Most of his work in course 17 was at the PhD level, and he was awarded the William L. Stewart Jr. Award in recognition of his undergraduate thesis on the Lincoln-Douglas debates of 1858. Maybe we can get him to do a presentation of that next. Erik was inducted into Phi Beta Kappa in his senior year, and while I love this line. While at MIT, Erik taught calculus and differential equations, 1801, 1802, and 1803, to first-year undergraduates at the experimental study group. I was fascinated by that because I flunked 1801 and 1802. He completed a PhD in political science at the University of Texas at Austin in 1993, where his studies focused on multi-method research, statistics, and political economy. He taught political analysis at Carnegie Mellon and then moved to the DC region to be the executive director of a scientific society in the policy analysis and program evaluation field. After 11 years in that capacity, he became an independent consultant to nonprofit organizations with a focus on data collection and analysis. And he's also, most importantly, the current administrator of the MIT Club of Washington. Erik has taught policy analysis at Carnegie Mellon's DC campus, at American University, at Georgetown University. He's the author of a textbook called Methods of Policy Analysis, Creating, Deploying, and Assessing Theories of Change, which you can get at Amazon now. And since 2017, he's taught the course Nuclear Weapons Technology in the Georgetown Security Studies program. Like many people, he got interested in Titanic with James Cameron's 1997 movie, which I suspect we all saw. He redirected as he reviewed the explanations of how the Titanic sank, he changed his mind about the Titanic with his perspective as a scientist, and he differs a little bit from what James Cameron said, so we're going to hear his view tonight. So with that, I would echo his words to turn off your sound and your picture, and I turn it over to Erik.
Well, thank you so much, Ann. That was really terrific. Thank you for that introduction. And welcome, everybody. Again, please turn off your video and mute your audio so that you don't become the speaker by mistake. What we're going to do is we're going to take questions in the chat. Please put any questions you have in the chat. And at the end tonight, we'll go through as many questions as time allows until we get to 8:30. I'm hoping to be done talking to give plenty of time to go through those questions. But that's how we'll do it, is through the chat. And again, thank you all for coming out. I want to also thank up front Henry Chu, who's the Vice President for Programming for the MIT Club of DC. Henry was really gracious not only to accept this proposal for this talk, but also to schedule it here on April 14th, which is just a couple hours shy of the 110th anniversary of the sinking of the Titanic. I thought it was really great timing to do it that way. So I want to start out tonight by emphasizing first and foremost that this is a talk about how Titanic sank, not a talk about why Titanic sank. Titanic sank because it slammed into an iceberg at high speed in the middle of the night, ripped a 300-foot-long sort of gash on one side of the ship, separating the plates on one side of the ship on the starboard side. Tons of water flowed in per second until the ship lost buoyancy and sank to the bottom of the Atlantic. And that's sort of the story of why Titanic sank. How it came to hit that iceberg, fascinating stories and amazing analysis that's out there. A lot of people are very engaged in that story, but that's not what we're about tonight. We're really about what happened as the ship went down, which is really, to me, a very interesting mystery, and one that has actually not been tackled very much from a scientific perspective. And I'll go into that in a little bit to explain exactly what I'm talking about. But I'm bringing up the issue of science because I want this talk to be as much about science and what science does as anything else. And this is a time in our country's history and our world's history where there's been a lot of discussion about the role of science, about the public's knowledge of science. And I think this is a fascinating example to show what science does, how science works, how science solves problems, as an example of the conduct of science. And I think we just all need to be involved in trying to encourage scientific literacy. And that's one of the reasons I wanted to give this talk, to show how science can address a mystery and get someplace different than where others who do not bring a scientific perspective have gotten to it. So let me tell you a little bit more background about this talk, and Anne hinted at it in the introduction. In 2012, which was the 100th anniversary of Titanic, a decade ago, of the sinking of the Titanic a decade ago, there were a series of specials that were broadcast. And one of them, most notably, which also turned up as the lead story in this issue of National Geographic of, I think, April 2012, was by James Cameron. It was called Titanic, the Final Word. I should note, it was not the final word on Titanic, and James Cameron didn't mean that. It turned out it was James Cameron's final word on Titanic. After that special appeared and this coverage appeared in National Geographic, to my knowledge, James Cameron has walked away from the Titanic topic and was done with it. So it was his final word on Titanic. But in that special, he brought together a large group of experts of various backgrounds, historians, naval engineers and architects, other people that had studied Titanic or been down to the wreck, to sit and have a final discussion about what happened when the ship went down and how it broke up. And I'm going to show you really quickly what motivated that conversation. About that exact same time, the following was made available for the first time ever. Give me a second, I'm just sharing my screen. The following was made available for the first time ever. And that was this map of the wreck site done as a sonar survey by remotely operated vehicles. Okay, can everybody, and if anybody's having difficulty seeing this, let me know, but hopefully you can see that I'm sharing my screen and you can see what's on the screen. But somebody please do unmute and tell me if you have any problems seeing what I'm trying to show you. So this seismic survey is a little bit difficult to see in black and white, but I'm just going to take you through it. So it's oriented north to south. So the top is north and the bottom is south. And this is the bow section, the largest, most intact piece of Titanic. The most northernmost pieces of the Titanic is this little piece right here, which is one of the hatch covers that blew off when the bow section slammed into the floor of the Atlantic. If you go down to the south, you come to the rest of the debris. And this is actually the picture I put in the advertisement for the talk. This is the stern section. It is notably in very poor condition, very mangled, and also facing backwards. These are the propellers, or on this end, this is the aft fantail. And the two large engines are sticking out the front of this section right here. So it's oriented backwards. And then there is an area of heavy debris. There's a very, very large piece of debris right here, multi-story high piece of debris, and we'll be talking about that. There's long strips of what is called the shell plating, or the outer hull of Titanic, lying around in this area. There are boilers here that fell out of the boiler room that was closest to the engines. And then over to the northeast from the stern, there are three really noteworthy pieces of wreckage. These two pieces are part of Titanic's double-hulled bottom. And this is the part that would have fit directly in front of the engines here, and a part of where Titanic broke apart. But even farther to the northeast is a very, very odd piece of wreckage. And what really got my attention was that at the very beginning of Titanic, the Final Word, the James Cameron special, with all of his experts sitting around the table, James Cameron announced that they were not going to discuss this piece of wreckage, that he didn't understand it, it didn't make any sense, and therefore they were just going to leave it off the table. And right then and there, my inner scientist sort of went crazy, because if you have a theory that tries to explain something like how this ship broke up and ended up in these pieces on the bottom of the seafloor, you cannot take off a big piece of wreckage because it doesn't fit your theory. Instead, what it is telling you is probably your theory is wrong. And as a scientist, that's what you have to do. If there is disconfirming evidence, you have to take it off the table. And sorry, you have to take your theory off the table, not the evidence. The evidence always stands for itself. And what's interesting about the wreckage on the floor of the Atlantic here is that it tells its story. It represents what happened, regardless of how we interpret it in any one way or another. The evidence is still here, and it is relatively incontrovertible. And I'm going to recreate this diagram in a minute, because I know it's hard to see all these pieces because the sonar map is only in black and white. And we'll redraw it in a way that we can talk about it in greater detail. But I just wanted to show you that what I'm going to redraw for you is based 100% on this actual evidence. You can look this sonar map up online. You can get this image from a variety of places just by searching for Titanic wreckage field yourself. Now, I want to stop here, and I want to just take a little side trip into the world of science, okay? And I'm going to share a different screen now. I'm going to share what I'm going to use as my whiteboard. Give me a minute here to bring it up, which is a device I have that allows me to draw for you, okay? Again, if you're having trouble seeing this, this device, I hope that somebody will unmute and tell me, but you should be right now seeing my hand, my beautiful MIT brass rat, thank you very much, right here on this piece of paper. So I want to take a little side trip into the world of science and address something. How do scientists come to say that something in the world, some theory that they're positing about the world is likely to be true, right? How do they come to say that? And the answer is there's something called the 4 C's of truth. This is one of the most important things I learned in graduate school. I learned it from a professor named Gavin Duffy, really a great guy. He was a PhD from MIT and went down to the University of Texas, was on the faculty there when I was a graduate student. This is distilled from a lot of material, but I love this. So the first C of truth is correspondence. In other words, we come to say that something is likely to be true because what we're saying corresponds with something that we can measure in the real world, like where the debris is that Titanic left on the floor of the Atlantic. Our theory corresponds to what we see there, okay? And then we have coherence, which is logic. What we're saying is logically consistent, it is internally consistent, it isn't self-contradictory, it makes sense from a variety of perspectives in terms of theories and understandings of the world. And I draw a line here because I love correspondence and coherence. They are great foundations of seeking truth. The last of these C's get a little shaky. We have consensus, which is basically what the experts say is true and have come to believe is true. And sometimes consensus is great, but sometimes it becomes a roadblock to actually getting somewhere and establishing another view of the world. This is sort of what the structure of scientific revolutions, Thomas Kuhn material is all about, is the role that consensus can play in holding science back. And lastly, we have the worst version, which is cash value. Cash value truth is if I say something, then I will be enriched because I said it. People will pay me, in essence, to say this. Now, I want to just back up and say that I'm going to be saying some things that are critical about what James Cameron proposed in his theory 10 years ago, but I want to make it clear that I have utmost respect for James Cameron. The man is an amazing, amazing, adventurous explorer, far braver than most of us probably could ever be. In addition to spending so much time actually on Titanic in submersibles, exploring its interior with remotely operated vehicles, which is not a trivial thing to do when it's down 12,500 feet, I believe he became just the 3rd person in world history to reach the deepest point in the oceans, the Challenger Deep of the Marianas Trench, in a submersible that he had custom built for himself. And he went down there, it was a 1-person submersible. He went down there 37,000 feet, The submersible only lasted down there about an hour before it started to malfunction. He managed, fortunately, to be able to return back to the surface. But this man is an amazing, adventurous explorer, and complete respect. But he is not a scientist, and it really showed in the Titanic Final Word special, and in the information that the National Geographic published based on that special, which quite alarmingly to me they treated as if it was absolute truth. And as you will see tonight, I don't think it is. In fact, I think it was substantially wrong. So in that special, there was a lot of consensus going on among the experts that he gathered together, but the basis for that consensus was from survivor accounts. Now, there's a lot of material related to survivor accounts. There were 2 inquiries conducted, one in the United States and one in Britain after the sinking, hundreds of hours of interviews and transcripts, and all those materials are available. And many of the experts that have delved into Titanic have started with the survivor accounts and then tried to make the wreckage agree with the survivor accounts and come up with theories about how Titanic fell apart as she sank that agree with the survivor accounts. I think this is a terrible mistake, because one of the things we know is that individuals who are experiencing stress, like the fear of death in the middle of this terrible disaster in the North Atlantic, in the cold, in the dark, that their accounts simply are not reliable. Science has already shown that these kind of accounts are not reliable. It's shown in the case of criminal forensics that witnesses to crimes often are incredibly unreliable in terms of identifying people who might have been the perpetrators. Individuals have gone to jail and served decades of their lives based on survivor accounts that are completely unreliable. This has been well documented. And the other problem is that the survivors had days to talk among themselves and reconcile their different impressions before they were ever interviewed. And that further confounded the accuracy of what they're saying. And finally, I just want to point out that when Titanic actually sank under the waves, she did so in complete darkness. In the James Cameron movie, when the lifeboats go back into the debris field to try to rescue a couple survivors, they have flashlights, but there were no flashlights at all. They did not have much of any means to light at all. When Titanic's electrical systems failed and the ship went dark and sank, the only source of light was starlight. The moon was not up, okay? And starlight is not very much light. And when the ship went dark, it would have been more like a dark, dark black object in the middle of an already dark, dark black ocean. And so the survivor accounts cannot be based on actually seeing things accurately because it occurred in the dark. And lastly, I just have to point out how cash value came to play a role here. Unfortunately, many of the experts that James Cameron gathered in that special to talk about how Titanic sank were people who had relied on James Cameron for their access to the Titanic. And when he'd been very generous in that regard, he spent much of his own personal fortune on expeditions to the Titanic. And I just felt that, and I could tell, and if you go watch the special, it is available online, you can see the degree to which they're biting their tongues and holding back some of their views because they don't want to contradict the person who gives them access to the wreck. Of course, what they didn't know was that was James Cameron's final word on Titanic, and he didn't go back to the wreck ever again. Okay, so some of them were kind of stranded without access for a while because of that. I'm going to be spending tonight talking about correspondence and coherence and building a theory of how Titanic sank that combines these two together. It has to correspond to the wreckage on the seafloor, and it has to have logical consistency and make sense from a variety of perspectives regarding our knowledge of the real world. The last thing I'm going to point out before I get back to Titanic in depth is that in the Titanic Final Word special, which again, this material was ported right into the National Geographic, there are many animations of how Titanic sank, not simulations, which have to abide by physical principles, but animations. And the problem with animations is that, with animation, you can have a coyote fall off a cliff for 1,000 feet, make a nice hole in the bottom of the ground, be hit by 4 boulders coming down, and then climb back out and buy another Acme product and try and get the Roadrunner. But friends, don't try this yourselves in real life, right? Animations, if they're not constrained by physical rules, can do anything. Magical things can happen. And as I'll talk about in terms of what happened with Titanic, some of what James Cameron proposed is very magical and does not seem to be based on any real understanding of physical principles. All right, so let's go back into Titanic now. And if everybody, I can hear people's voices. If you'd be so kind as to mute your microphone, I'd really appreciate it. Again, we will take questions in the chat, and please put them in the chat. So let's go back and talk about Titanic a little bit, and I'm going to recreate that wreckage field for you now, okay? So I showed you the sonar map, and now I'm just going to draw it again freehand, okay, here on this piece of paper. And again, I showed you the sonar map so you can know I'm not making this up out of whole cloth. I just want to clarify it, make it a little easier for you to see. So look, you have the bow section up in the north, like this, okay? And then you have the stern down here, but facing backwards, okay? So the propellers are actually here, facing backwards. Then you have a very large chunk of debris right here. You have a very heavy debris field right next to this area with these boilers from one of the boiler rooms in there. And then over here, you have two pieces of Titanic's double-bottomed hull, I'm sorry, lying on the seafloor. And then you have this very strange piece of wreckage right here, right? Now, in the Titanic Final Word special, James Cameron tries to explain all of this wreckage, but this piece right here, based on the notion that Titanic was sitting over this point right here, that this was ground zero, what he called ground zero for the breakup, right here. Titanic is sitting right here. Titanic breaks into at least two pieces on the surface, okay, and this is what's also depicted, of course, in the 1997 movie. Titanic breaks into two pieces. The bow section heads down by itself. Eventually, the stern section sinks. It bobs around for a while on the surface. It sinks. And to get this configuration of material, except for this piece right here, he has the stern section corkscrewing around rapidly as it sinks, tossing pieces off. And he has these two pieces of the bottom, what he calls butterflying off. They're kind of have a hydrodynamic shape, and sort of they can fly in water, and they sort of just flutter over here and land here, okay? But it all starts in this point. But I had a different thought as soon as I saw this pattern, and especially this piece right here. This piece right here doesn't have any hydrodynamic properties at all. It could only have gotten here if it fell directly here from directly above. But how could it have fallen from here directly above if the rest of the heavy debris field is here around the stern? Well, there's one possible answer, and that possible answer is that Titanic was not stationary at the time that she began to go down, but instead that she was moving, and she was moving in this direction. She was adrift in the current, okay? And if she was adrift in the current, then that means that this is the first piece that comes off. And then as she moves, these pieces are the second pieces that come off. And then you get this structure happening over here and this as well. But you have a dynamic process where the ship is actually adrift in the current. Now, was there a current? Well, there definitely was a current. There's some questions we're going to look at in a minute about which direction it was moving. We know there was a current. In fact, there was an incredibly powerful current that night, because it was that current that was pushing the icebergs from the north deep, deep south into the shipping lanes. The ice was not supposed to be there. It was an unusual circumstance to have this much ice in the North Atlantic shipping lanes. It was there because of an incredibly powerful current pushing from the north, okay? And so there is evidence that something was pushing, maybe not just from the north, maybe from the northwest. We'll look into some more details about that. Before I get there, though, I want to itemize some other mysteries here that we have to address in putting forth a theory about how Titanic sank. This is, again, something that I find scientists do that other people don't automatically do. We ask obvious questions that don't have obvious answers, okay? And here is one of the biggest mysteries about Titanic that I've always wondered about as a scientist. Remember, this is approximately north. Why is a ship that is going from England to New York City, in other words, from east to west, why, when it sinks, is its wreckage predominantly pointing north? How did that happen? I've never seen anybody in the Titanic world, there's a lot of people out there in this world, actually ask that question. Why is the ship pointing north when it was heading west? And remember, it was loaded with water. by the time it sank, it was loaded with water, and it was incredibly, incredibly dense. And it shouldn't have been easy for it to turn directions. I am hearing one person's audio. If you could please mute your microphone, I would appreciate it. You know, why is it facing north when the ship was heading west? Why isn't it facing west? Okay, so that's one of the first questions that I come up on. There's some other things. I'm not going to show any pictures of this. You have to take my word for this. At the back of the bow, all the decking at the back of the bow is slammed down very sharply where the bow section separated. It very steeply slammed down. James Cameron thinks that happened basically from the impact on the seafloor, and also a water column that the ship was dragging behind it, hitting the ship and pushing the steel down. But there's a problem with this. There's several problems. I'm not sure that the water column and anything can push steel like that. In an animation, yes. In a simulation, I'm not so sure. But if you look at A and B deck at the very back here of the Titanic, what you see is that they are wrapped around each other like this. They're not just pushed together. B deck is almost wrapped around over the top of A deck. It took tremendous force to do that. Something else that James Cameron concludes that because he believes the Titanic stern was corkscrewing down, that the only reason that it has almost exactly the same alignment as the bow is a complete accident, just random chance. It ended up with this same north-south alignment as the bow, just randomly. I think so many different random chances have to happen here in that theory to get here that the probability of all put together strikes me as being vanishingly small. Something else that I'll take my word for, you can look at pictures if you want online. At the back of Titanic, the poop deck, and I'll show you where that deck was, a decking area right about here, has been folded sharply over itself like this and is upside down. It's pointing upside down. Here's the very back of the ship. This deck has been wrapped backwards and is sharply backwards and smashed back down flat. There's different theories about that happening. I'll talk about in a minute. I don't think those theories are correct. I'll give you another theory of that. But to me, it looks like something actually grabbed that deck and literally just with tremendous force pulled it backwards and bent it down over itself. And we have to ask what could have done that. And then again, and something else that I noticed when you look at this debris field, and there's been a lot of conversation about this recently among experts that have written about Titanic or have videos online, the debris field is too small. If Titanic broke up on the surface, this debris field is too small. Even though it takes up a very large amount of space in many ways, it is still too tightly clustered together for a ship to have broken up on the surface and fallen 2.5 miles to the seafloor and ended up with this compact arrangement. And it begins to raise the question, did Titanic actually break up on the surface? And the other thing I noticed as a scientist is that overall the entropy of this debris field is very low. Now, entropy is, for those of you that studied thermodynamics or avoided thermodynamics like the plague, entropy is a concept that has to do with the relationship between the microstates of a system and its macro state. Now, this is the macro state. The microstates are what you get when you get very close down in and look at individual little pieces, okay? If you have a situation where you can rearrange the microstates in many different ways and the macro state looks the same, you have a situation with high entropy. But if you have a situation where you cannot make those rearrangements without changing the macro state, you have very low entropy. And to me, this is a site with very low entropy. And when I see low entropy, I begin to think about deterministic processes, not probabilistic ones, resulting in this structure, okay? So I want you to keep that in mind about how to look at a scene like this and tackle it from a scientific perspective. Okay, moving on now, let's talk a little bit more about each one of these issues I've raised up about why is the wreck facing predominantly north? Why does it have this arrangement of material? Could the ship have been moving in the current at the time that it broke up? How did it break up? And if it didn't break up on the surface, where did it break up? Okay, so let's start out first off with the current issue with where the Titanic was moving. So what I'm going to do now is I'm going to show you two pieces of information. Two pieces of information about the Titanic site. Again, folks, I'm hearing people. If you could please mute your microphones, I would really appreciate it. Okay, I'm going to now draw you the coordinate, two sets of coordinates that are really relevant for understanding what happened with Titanic. So these are latitude and longitude coordinates, okay, on the surface of the ocean. And let me just draw these really fast for you, and then fill them in and show you what the information suggests. Let me just finish this over here.
What a presentation.
Okay, so
American professors.
Ladies and gentlemen, I'm still hearing people on their microphones. If you could please mute your mics, I would really appreciate it. Okay. All right. So this is 51 west. This is 50 west. This is 42 north. And this is 41 north. And this is the position that Titanic reported when it was sinking. When it was asked to report its position, this is the position that it reported. It said that it was at the SOS signal when it was signaling, said it was at 41 degrees 50 minutes north and 50 degrees 14 minutes west. And this is where Titanic said that it was at the time that it sank. But actually the wreck is over here. The wreck is located right here. It is at 41 degrees 44 north and 49 degrees 56 west. So, and this is one of the reasons why it was hard to find Titanic, was because of this discrepancy between its last reported position and where the wreck actually was. But what you can see is two things. First off, the actual position of the wreck is south of its last reported latitude, and it's also to the east of its last reported longitude. Now, the fact that it was south of its last reported position is consistent with the current that was pushing from the north, okay? That is completely consistent with the current pushing from the north. But the fact that it was to the east is a little inconsistent with that arrow I showed you before inside my diagram of the wreck site. But I have some doubts about the longitude measurement. So latitude is very easy to establish even in the middle of a crisis, because it has to do with the altitude above the horizon, the elevation above the horizon of known landmarks or stars or whatever that you can use and compare and get your latitude correctly. But longitude, as you know, is hard. Longitude in those days was generally established accurately only at noon during the day, when you could compare a clock in your ship that was showing you the clock at Greenwich Mean Time with noon where you were, and the discrepancy between those two would give you your longitude. And then after that, you estimated your longitude by reckoning your velocity, not just your speed, but also your direction, your velocity, and calculating how much further you had gone from your last known position. It wouldn't surprise me in the middle of the Titanic disaster that they messed up the longitude calculation. But I have to take it as a point that this direction of movement is inconsistent with the one that I see in the wreck field. I'm just going to put that out there and acknowledge it. I personally believe it's not as big an inconsistency. There could have been other factors at play, but definitely Titanic was being pushed to the south. And that's a really crucial point to make. So we have some evidence that Titanic was moving. I'm going to go back to the Titanic wreck again. We have evidence that Titanic was moving and being pushed by the current. And again, this would be moving from the northeast to the southwest, which is not consistent, again, with what I showed you before, unless the longitude was messed up. If the longitude was messed up, it could be very, very consistent, okay? All right, so Titanic was being pushed in the current. And here's the next thing I want to point out, is that here's the ship. Here's my hand is going to be the ship temporarily. You originally were going in this direction to the west, but as you start to sink and you're being pushed down in the water, and the bow of the ship is in the water, and you're in the grips of this powerful current, the ship will turn toward the current. It will twist toward the current. Not only will it move, but all the lifeboats that are around the ship, they also will be pushed in the current. The whole ensemble will move together. Relative to each other, the lifeboats in the ship will appear stationary, pretty much stationary, but they will all be pushed and turned in the current. And I think the reason that Titanic's bow section, at least, points pretty much to the north is it's pretty much pointing in the direction of the current. And the ship was turned by the current. But that's the same current that's responsible for this movement as it sank, okay, to the point that it finally came apart. So that's the first, my theory starts with that first answer. Why is the bow section facing north instead of west? It was pushed in the current, the same current that's responsible for this drift. Okay, that's point one. Point two, what about how did the A and B decks get so crushed together? This is going to get to one of the most important differences I have with James Cameron's view and many other people's view of Titanic. So to do this, I'm going to bring up the first simulation, not animation, the first simulation I'm going to use tonight. I've got two of these that are very simple. I'm going to start with one before that. I'm going to start with James Cameron's only simulation. The only simulation that James Cameron uses is the banana. And I kid you not, you can go see it for yourselves, folks, the banana. So James Cameron has the banana explanation of Titanic. And it looks like this. The ship is beginning to sink. The bow section is being pulled under the water. The stern is still floating. The stress is built up here, and Titanic breaks like this. And then the bow hangs down, and this is the part of the double-hulled bottom that hangs for a while before breaking, and then Titanic separates like this, and then the stern eventually sinks behind it. This is the James Cameron banana simulation. But it begins with the notion that Titanic breaks at the top of the ship, and that, I'm going to show you, is probably completely false. In fact, there's much evidence that Titanic did not break at the top of the ship. Titanic broke at the bottom and actually held together at the top for a very long time. So here's my first simulation of the evening. It's this paper tube from a roll of paper towels. It has to obey basic physical principles. I didn't come up with this. A person put up a website about Titanic after the movie came out and complained about James Cameron's view of the breakup and used this and said, this is what you should think about is this type of tube. So here is our tube, okay? And it's going to represent the ship, right? This the basic exterior structure of the ship. This is the stern back here, and this is the bow. And again, we're going to let the bow start to sink. And the bow is going to sink, and as it goes, it's going to bend down like that. And please look at that structure. Please note that it bends over the top like this, okay? But it crushes in the bottom. It absolutely crushes in. And this is in fact what I think happened with Titanic. It crushed in, and we'll talk about where in a little bit. And then those two pieces of the double-bottomed hull broke free, okay? They broke free from where it crushed in, all right? And that was the first real separation of Titanic, was the crushing in from below and the breaking of the double bottom hull. Not at the top. The top got bent over like a curve and smashed together. And this is part of how you get at the back of the bow section, the decks all smashed down together into a slope is because of this process. To see it in a slightly more detailed way, I have a second simulation for you. This is tinfoil. And it's actually, I don't know if I can see inside, but it's actually multiple layers of tinfoil wrapped around each other to represent the different decks. And we're going to do the same thing with this simulation I did with the paper towel. We're going to sink Titanic. We're going to have the stern, the bow. We're going to have the stern start to sink and pull down, and we're going to have it bend and bend and bend. And I want to show you something. I'm not sure if you can see it directly. But if you look here, you will see that inside this part here, it actually has curved in. In other words, it looks just like this. It is curved in where the decks are wrapping around each other and making a curved shape. And this again is exactly what I think what happened when Titanic began to sink. She crushes in down here and she breaks down here. She wraps around here, but you get this C shape naturally from the crushing of the decks together at the back. Now, what we need to do now is we need to talk about this piece of wreckage right here. And what is this piece of wreckage? Because this is another really important piece of evidence. So to do that, I am going to use another exhibit. And to do the exhibit, I'm going to have to turn my computer, which I'm going to do very slowly because the one thing I don't want is any seasickness while we talk about the Titanic. All right. So I'm going to have to lower my computer, and I'm going to turn it over here, and we're going to take a look at the Titanic in a little more detail. Okay, hopefully you all can see that. I'll walk over here and make sure you can see it. All right, for those keeping score, this is the Lego Titanic, released November 1, 2021, 9,090 pieces. A really good time if you have the time to build it. I highly recommend it. Okay, let's talk about this piece of wreckage that is the easternmost piece of wreckage that's been found. But let me talk a little bit more about the breakup first. Titanic's bow section that lies on the floor of the Atlantic extends to just behind the second funnel, to just here. It extends to just here, okay? The stern section extends to just in front of the fourth funnel. The engines are sticking out from the wreckage right about here. This section here that's under the third funnel completely disincorporated and is represented by multiple pieces on the bottom of the seafloor, okay? But that easternmost piece of wreckage that I showed you, that easternmost, oh, hold on one second. Somebody just came in to tell me I forgot to turn off my whiteboard. Hold on. You're not seeing the wreckage. Hold on. You're not seeing the Titanic. Give me a second. I apologize for that, everybody. Let me stop my share. There we go. Sorry about that. Let me turn it back to the Titanic. Sorry about that. Thank you so much for someone who came in and told me that that I had forgotten to do that. Hopefully you can see the Titanic now. Again, the Titanic's bow section goes to here, just behind the second funnel. The stern section goes to just in front of the fourth funnel. This section is the part that is shattered at the bottom of the Atlantic. And that easternmost piece of wreckage, is what is directly underneath the third funnel right here. This unit that is directly underneath the third funnel was the easternmost piece of wreckage. It's just basically a metal box that was built around the base of the funnel, and it broke loose at its structural integrity to hold together, and it broke loose, and it is the first thing that came off of Titanic in terms of how the ship came apart, according to my theory. And again, this is the Lego Titanic, 9,090 pieces, and I highly recommend it to those of you who like to build Lego. So let me turn back now, and let's return to discussing what happened here in my theory, and it was particularly with regard to this piece that is directly underneath the third funnel. Let me I'm gonna raise up my computer again and turn it back. Give me 1 second. All right. Okay, and I'm going to go back and use my whiteboard again. So, and again, I apologize for that brief mistake. Okay, so back onto the whiteboard. This piece right here, again, is the piece that was directly underneath the third funnel. It's very odd that it would be sitting there as the far eastern piece of wreckage. But let's look at what actually likely happened that night. I'm going to make another drawing for you, but again, I'm going to base it on the simulation of Titanic behaving like this at the time that it was sinking. And the area where the third funnel was is directly above this point where Titanic crushed in from below. Okay, so I'll just draw a little diagram here for you of what I think Titanic looked like at the time that it began to disincorporate. So the stern will be, the bow will be here, the stern will be here. You have the bow section is down in the water, but things are bent over very severely toward the stern. This is the area where the third funnel was, directly above this point. This is where the two pieces of the double bottom break off. But just before that happens, the superstructure up here, severely stressed and made of wood, by the way, not metal, mostly made of wood, comes apart, and the third funnel falls off From the perspective of people watching this, they would have seen the third funnel fall off the ship. The first and second funnels probably had already fallen off at that point. And with it, this unit under it goes and falls and becomes our first piece of wreckage. The second thing that happens is that the double bottom gives way. Right here, again, exactly as our simulation shows, it crushes in and gives way and becomes the next thing to fall to the bottom. But then we have a question about what happens next. And here's what I think Titanic looked like as she went down. She did not separate completely on the surface. Instead, she was held together. This is going to be the bow section. Crushed in the back, crushed down in the back, connected loosely to the stern. She sank looking like this for a long time, maybe even half the way to the seafloor, where there's a huge opening in the bottom of the ship. And what's holding the ship together are the decks and the shell plating right here, approximately where the third funnel was. Now, this is not a stable arrangement. It is eventually going to come apart. The question is, how did it come apart? So this gets a little tricky. I'm going to give you a couple different thoughts of what might have happened here. What I think happened here is that eventually, descending through the water column, you have this whole opening here, this heavy opening here, and water pushing up inside this. Now, I'm going to stop and I'm going to back up now and explain what everyone else has been saying about the stern section. So the stern section is a complete wreck on the seafloor. It's got pieces of shell plating draped across it. It's very mangled. And the general explanation that people have used for it is that it was subject to an implosion. That is, it was filled with air, it was dragged underwater, and eventually the water pressure crushed in the stern. And when it crushed in the stern, the lots of things shattered and twisted. One of the experts on the Titanic is part of a new video that just came out this week, where he talked about how the force of that implosion and then the air escaping from the stern is what bent that poop deck back over the top. I don't believe any of that. Vessels that suffer implosions under the water are often shattered into little teeny bits, not large coherent pieces. But the other problem I have is that the place where most of the air would have been retained in the stern section was at the very rear of the stern, and that is exceedingly intact. It is very, very intact. It shows no sign of implosion at all, yet that's where the implosion should have taken place. Here's what I think happened. You have the ship held together very loosely by the decks and by the shell plating here, but under tremendous force, water pressure pushing here. Then you have to decide what happened to the stern section. Did it fold under its weight like this and sort of smash like that for a while before separating? Or, as I think is more likely, it actually did something very bizarre. It actually bent over backwards like this on the top before it separated. The reason I think it bent over backwards is at the time that it separated, I'll use my hands now to represent this instead of a tube. At the time that it separated, it bends over backwards. And as it breaks loose, part of it is still grabbed on by the section in front of it. And it's that grabbing as it separates that bends the poop deck back over on itself very sharply and presses it down. That's as far as I want to go with that. It's a little speculative, but that's what I think happened there. But I want to point out something more important. Whether this stern section bent down like this as it sank or bent up like this as it sank, please note that either way, the propellers, for two things. First, note that it is still in line in general with the orientation of the bow, but the propellers are now facing the other direction. And then when this breaks off, what it does is from its own weight, it simply is going to right itself and land on the seafloor, but facing backwards, okay? So that's how the stern comes not only to be facing backwards, but as we saw before, I'll go back to that diagram. Not only is it facing backwards, but it is in approximate alignment with the bow section. This is not an accident. This is actually part of a deterministic process that kept these two components pretty much on the same axis, just offset a little bit. Okay. And in building this theory, again, what I've been trying to do from a scientific perspective is also follow what often is called Occam's razor, which is to have the simpler explanation that gives you the result, not the more complicated one, not the one that has an object corkscrewing down for 2.5 miles. It's somehow miraculously ending up with most of the pieces that it is supposedly tossing off, landing almost directly on top of it, which I find very improbable. Also, when it bends up like this and then breaks loose and rotates, it breaks loose on one side before another. It's going to wrap shell plating around the top of itself, which is exactly what it looks like on the seafloor. It's going to have other pieces strewn around nearby. Now, the other piece I want to point out to you, this large piece of debris that's right directly in front of it, I'm going to just say that that piece of debris is also from part of the Titanic that was very near the third funnel. And it was a unit that was very strongly connected to itself, and it probably broke free at a certain point, well down into the water column, maybe halfway down to the bottom. It broke free and separated and kept its integrity as it separated from the stern. It could have even been the process of this breaking free that helped to bend that poop deck back over itself. All right, the last thing I'm going to do before I move to questions, we're almost at 8 o'clock. Is I want to talk about something else important about science, which is that when you have a theory, it should have testable implications. And one of the testable implications here is I've always wondered what you might find if you explored a little farther in this direction, away from the known map of the debris field, what you would find over here. And I think you would find more Titanic debris from the early part of the breakup in that direction. And if you did, it would help to confirm some of this. What might you find there? Well, as far as I know, the fourth funnel is here. I've never seen any of the other funnels in this debris field, but I could be wrong. But I've never seen any other funnels in this debris field. I don't know where the third funnel is, and I'm wondering where the first and second funnel are, because they definitely fell off early in the sinking, and I think they're over here. And they were very strong structures. They were highly reinforced because they were carrying very hot gases, and they had to be double walled in order to keep the heat contained on their interior. They would have been pretty strong, and I would believe, if my theory is correct, that you'll find the first and second funnels in this direction. But kind of grim, you had a lot of people in the water, and they were eventually drowning and sinking to the bottom. And they were also gripped by that current. And I've also wondered, if you explored further in this direction, would you find more evidence of human beings having lost their lives and sunk to the bottom of the ocean in this direction? And this axis, if it proved to be fruitful to explore in both directions, would help to better verify my theory. But I put out some testable hypotheses that people, in fact, could test. Okay, so there is a theory for how Titanic sank. The Titanic did not break up on the surface. Titanic broke up well under the surface. The Titanic did not break up from the top. Titanic broke up from the bottom. That Titanic was in motion across the surface as the ship broke up. That Titanic had been turned by the current to face to the north. It was that same current that resulted in this motion as it sank and this pattern of debris. This was the first major piece of debris. This is when the bottom gave way. This is when serious breakup began. And then someplace around here is where the bow section separates from these other two sections. And also there's a process whereby the stern doesn't corkscrew to the bottom. It gets pulled close to the bottom. It gets turned around as it falls off and rights itself, but facing backwards. Okay, I hope that in doing this, I have gone through some principles about using science to explain a scene like this. I'm now going to stop my share, and I am going to go over to my computer a little closer, and I'm going to go through your questions for the remainder of our time together. So let me go over a little closer to the computer here, and I'll just raise it up, and I will be able to look at your questions better, okay? All right, so thank you again very much for listening to this. I hope it's been thought-provoking. I hope that it has made you think about science a little bit and the role of science, about using simulations, not animations, about having testable hypotheses, and about trying to figure out how real physical systems work under stress. Let's look at the questions I have. First question, I'm going to take these in the order that they came up. So let me just go up to the top. Let's see here. What is the size of the debris field? The total size of the debris field, as I recall, is approximately 15 square miles. It's a big debris field, but again, it's not as big as it should be if the ship had broken up completely on the surface and fallen down 2.5 miles, fallen out 2.5 miles to the seafloor. There have been other sinkings where there's evidence that shows that the debris field should have been a lot bigger if the Titanic had separated at the surface. So it's about 15 square miles. And if you look at the debris field, in addition to the major pieces of debris, of course, scattered across the debris field is lots of little stuff. There are benches, there are famously shoes, there's clothing they've recovered and brought up to the surface, jewelry, clothing, suitcases, letters, menus. There's plates and cups scattered all the way across the debris field. Let's see, another question. What made the stern fold up? Well, I have two ideas about that, but I think the general idea behind it is that the stern was folded up. It was heavy. Let me go back to my whiteboard and we'll look at that together. The stern was folded up by pressure on the stern as it descended through the water column. It was barely attached at all to the front of the ship, and my view on this is that, and I know it is very heavy, and you're right, the heaviness is a real issue for all explanations of Titanic doing things like corkscrewing around or falling through the water column. My view is that if you look at the stern section, let me go back over here to this picture that I drew. There's a huge chunk of Titanic that's missing down here. As it falls through the water, there are several things that could happen. It could just have simply been the water pressure that is pressing up into the ship right here and pushing against it and just pushing it up. It could have been that the whole unit actually corkscrewed around not corkscrewed around, just simply twisted as it fell. But the reason that I think that the stern went upside down is A, it helps to understand how it got turned around and facing backwards, but it also helps us to understand what happened to that poop deck again. Let me go back to the model of Titanic really quickly for you, and we'll look at the poop deck one more time on where that is, because that is one of the big questions. Before I get that, someone just asked, is there any plans to explore a wider area for looking at other debris? Well, there has been one expedition that has been in the news. In 2021, a company called Ocean's Gate took a specially designed, very large submersible and paying customers who paid to do this down and did an extensive survey of the Titanic debris field for many days. And they have been releasing videos online. You can, if you just look on YouTube for Ocean's Gate, you will see their videos. I do not know how much they went outside of the sonar debris field. And honestly, I can't remember whether or not the size of the debris field was constrained by what the remote operated vehicle sensed when it was down there, or if it was constrained by programming given the remote operated vehicle. But I do know for a fact that the actual debris field is bigger than the sonar map. I have heard several explorers talk about having gone kilometers in different directions outside the main debris field and still encountering debris. Okay, so there's a lot. It's a wider debris field than the one that the sonar map produced. Now I want to go back and look at the Titanic model again. Give me a second. I'm gonna push my computer down and we'll look at it again together. Let me make sure you got the ship in here. So this area right here. Let me tip my camera up a little bit. Maybe you can get a better view. The area that's bent over backwards is this deck right here. The top of this deck right here, it was grabbed and bent all the way back over the aft fantail of the Titanic. And I mean, with tremendous force, it is smashed down, okay, and bent over. And something had to have done that. Now, let me talk about the implosion theory a little bit. a little bit more. So again, the one expert that just had a video come out this week said that he thought that what bent this back was the explosive force of the air being pushed out of the stern during the implosion, and that force had to go somewhere. So it basically pushed this deck straight up and blew it over. But I don't see why it would do that. I can see it pushing it up, so it'd be like this. I don't see why it would smash it then back flat down. What could possibly have smashed it back flat down? Or why didn't it just knock it right off, right? And again, the implosion theory for the stern has just been used as sort of a MacGuffin to basically deal with the fact that the stern is such a mangled mess. And it's been difficult for experts to figure out exactly how it got in that condition. But I don't think it's difficult to understand how the stern got in that condition if it was essentially being held on to by the shell plating on this side and some of the decks, and then being twisted around as it fell. And it was the fact that it was twisting around as it sank to the seafloor, but still being held onto on the sides by these parts. And as it begins to twist as it sinks, that's where the real mangling takes place. And I don't see any signs here that this experienced an implosion. If you want, what's interesting is that we now know that Bob Ballard, he found the Titanic courtesy of the United States Navy, paying for it. He was on his top secret expedition to look at 2 lost US nuclear submarines. The Thresher, which is lost in 1968 in the Eastern Atlantic near the Azores, and the Thresher lost in 1963 off the coast of Massachusetts on a test dive. Now the Thresher experienced a full implosion, a terrible implosion. Bob Ballard described that submarine as basically what a submarine would look like if it went through a paper shredder. All that's left that's recognizable of a submarine is the sail. It's the only part that really survived. That's a scene with very, very high entropy. Clearly, a lot of stochastic processes in place there. And that's what an implosion looks like. An implosion doesn't look like a predominantly intact stern. And especially, as I said before, the very rear of the ship, where there would have been an air bubble if there was anywhere in the very rear back here, is in excellent condition. Okay, doesn't make the whole implosion story just doesn't make any sense to me in that regard. I would have expected if the stern was pulled under and suffered an implosion, we would have basically found little bits of the stern lying around, not a predominantly intact piece. Let me go look at some other questions people have before we finish. The bottom which includes the keel, is much stronger than the top deck. So why will it fold up? Well, you have to remember, folks, that the bottom had already broken already. Those 2 pieces of double hulled bottom had already come off the ship and were on their way to the seafloor, because when Titanic bent, the force was predominantly felt at the double hulled bottom and it broke. Those 2 pieces came off and you can see them on the seafloor. So once that happened, the bottom is compromised, okay? At that point, it could move, it could bend this way or it could bend this way, but the bottom isn't preventing any of this bending because there is no bottom there. I could have taken a pair of scissors and just cut it out to demonstrate, but this piece of the bottom is missing at that point. It is completely gone. All that's holding the stern section to anything in front of it is the shell plating on the sides and the decks, because the bottom is gone. Another question. There've been a lot of questions that come up. I'm going to get down to the next one. Would most of the rotation of the Titanic have occurred on the surface or as it sank? You mean, if that's the rotation from facing west to facing north, I think it happened while it was on the surface. I think once the ship sank, it was filled with water and sank, it would not have turned much in the water column anymore. That's my theory. The ship command was hard rudder to starboard. Could that have caused the vessel facing north? I don't know the answer to that question because I don't know what the ship command was for the. I know you're talking. You're talking. They put the rudder hard to starboard in order to try to avoid the iceberg. So this is something about Titanic that many people don't know. Great idea, except for this: after they hit the iceberg, for a brief period of time, Titanic resumed trying to move underway under steam. In other words, they straightened out the rudder and they tried to head toward New York. They did it for a little while until it became clear that continuing forward motion was increasing the rate of water going into the ship. And that's when they came to a dead stop. And at that point, the rudder would not have been turned one way or the other, okay? Because they did resume trying to sail to New York for a brief period of time. I didn't know that till 2012, but Titanic didn't sit still after hitting the iceberg. It resumed under steam for a brief period of time. The top of the tube is under tension, which is weaker than the bottom under compression, unless the top was built to be much stronger than the bottom. Thoughts? Well, all I can say is that the wreckage field indicates to me that the bottom gave way first, because that's what's lying farther to the east. And if my theory is correct that the ship was drifting, then we know the first piece to come off was the piece that was under the third funnel. And the second piece to break was the double hull bottom, which broke because it bore the brunt of this pressure, like I've shown with this tube. Okay, it was where there was far more force than at the top. The shearing force at the top was, in some sense, just released by the breaking of the bottom and the crushing in of the bottom. Those are my thoughts. Now, folks, I'm not a naval architect. Some people are, but that's what I think the evidence says at the bottom. Is it possible there was an area of lower drag following behind the bow that supports the theory of the stern flipping over backwards? That I do not know. Interesting idea, but I just don't know how large pieces like this behave in a water column. Neither does any, I've not seen any real simulations of this. Certainly James Cameron did not do a simulation of that. He used animations again, more than simulations. But I will say this, I take the point about the stern flipping upside down or flipping backwards, but you still have to figure out how that poop deck got ripped over 180 degrees. So it's ripped over and back and smashed down on itself. And that's why I came up with the idea that eventually going through the water column, maybe in this shape, the stern bends over, and then eventually it breaks loose. As it breaks loose and twists away, that's when a lot of that shell plating gets wrapped around the top of it, and that's when a lot of the damage is done. How far down? I think Titanic must have been at least halfway to the bottom before she separated completely. In other words, about 6,000 feet. It must have fallen at least 6,000 feet before it came apart. That's my best estimate. But you know what people saw on the surface, what they thought they saw, of course, in absolute complete darkness, would have been, you know, the bow section going under, and then this part crushing in and looking like things were breaking apart, and they were. And again, remember, the superstructure at the top of the ship is made out of wood, so it would have shattered apart and fallen off. But it's the metal decks and the shell plating that held together, or barely held together, as this ensemble starts to the bottom. And again, I'll refer back to the ship one more time, if you don't mind, just to reiterate this. Let me get the ship in view. So this section right here around the third funnel is what came completely apart into pieces and is scattered around on the floor of the Atlantic. Again, the bow section consists of this. The stern section consists of this, but this entire section broke into multiple parts. Something else that the 1997 movie didn't grapple with, and that was for, you know, thematic integrity and telling a story. It would have been too complicated to have shown a ship breaking apart like this in a movie, fine. But again, I do not believe Titanic broke like a stick, separating at the top and then breaking finally at the bottom, or the banana theory that James Cameron used. It broke apart at the bottom and then separated the top later. And these pieces all came apart maybe as much as 6,000 feet down before they separated. Remember, in the debris field, the biggest chunk of this piece right here is actually situated just in front of the stern. And I just don't think that's an accident. I think they were pretty closely connected until we got way down near the bottom. All right, let me come back one more time, look at some other questions that are on here. Okay, let me see. Did Woods Hole MIT provide any technical review before they went public? I don't know. I mean, there were people from Woods Hole that were involved in the James Cameron special. I've actually corresponded with one of them briefly years ago, Jeff Gallo at Woods Hole, one of the advisors. But, you know, honestly, I don't think James Cameron cared one little whit about any of that. He didn't have to, right? I mean, he's James Cameron, let's be honest here. I did not feel there was a lot of technical review. And again, if you watch the special, the Titanic, The Last Word special, you will see, I think you'll see some people biting their tongues because they have some doubts about what Cameron is saying. But this is why, again, to get back to the four C's of truth, let us return to the four C's of truth. What I've tried to do for you here tonight is I have tried to give you an alternate theory about how Titanic sank, in which coherence and correspondence, let me put these back up on the whiteboard, in which coherence and correspondence are all that matters. And I'm not that interested in the consensus, because the consensus has been driven, again, predominantly by the survivor testimony and not by the evidence on the floor of the Atlantic, which is not consistent with the survivor testimony. And unfortunately, it's not just James Cameron that's involved in the financial side of Titanic, but Titanic is an industry, okay? There's an industry of people who make their living off of Titanic, making videos on YouTube, giving talks, writing books. I'm not in that world. But what happens in that world is that the combination of consensus and cash value can start to compromise dealing with evidence. And the evidence on the floor of the Atlantic, again, is incontrovertible in terms of what it really means. We will someday figure it all out completely. And it's got many jots and twiddles to it that I haven't dealt with tonight. But the need to correspond with the wreckage remains, and the need to have a coherent explanation that fits with how steel works, about how ships work, about how debris fields work also remains. And I've tried tonight to give you a flavor of that. But and also just, as a scientist, you never say that your theory is correct or 100% true. You talk about how it agrees with the available evidence, and you're ready to modify it if evidence emerges that contradicts your theory. Evidence can emerge from a wide variety of sources. Here's some things about Titanic we've learned from these expeditions down there that have contradicted some previous beliefs. First off, Titanic steel was not brittle. Many people talked about Titanic steel being brittle, and perhaps that's why the ship was so easily damaged by the iceberg. The steel was not brittle. On the port side of the bow section, there is an amazing place where when it hit into the seafloor, the steel is bent into a fold, a very tight fold of the shell plating. It didn't break, it just folded. So the steel was incredibly strong and also pliable, even as cold as it was at the time. What about the rivets? People talk about the rivets. I've seen lots of different studies have done of trying to estimate what was going on with the rivets. I've never seen a single study that found there was anything wrong with Titanic's rivets at the end of the day. So people had rivet theories about why the iceberg damage was so extreme. Those have been pretty much been debunked by people actually gone down and looked at the rivets or brought rivets up and tested them. That's the beauty of having real incontrovertible evidence, is that you test yourself against it. You're as good as your fit with the evidence. You're as good as your ability to correspond with what's going on. All right, I have time for I think just a couple more questions. If there are any, I will check here in a second. And let's see. Are you saying we should not accept survival testimony? No, I'm not saying that, but survivor testimony has to be taken with an incredible grain of salt. Again, there's been a lot of really serious science done, but predominantly in the world of criminology, about how unreliable eyewitnesses are to high trauma events. They are not good at remembering key details. They are not good at remembering the identities or the descriptions of people who need to be described. There's been a lot of scientific research done where witnesses have a real tendency towards systematic error. And what they try to do is they try to make their memories cohere with their beliefs. And so memories that don't agree with their beliefs can get tossed off to the side. And there's extensive literature about this. And again, unfortunately, people have served long terms, and innocent people have served long periods of time in jail based on survivor testimonies that turned out to be completely erroneous on a wide variety of factors: skin color, age, height, clothing, all sorts of factors have turned out to be completely wrong. And this has been documented very extensively. So, I mean, yes, survival, and I'll say this, I was talking to someone who's been involved with air traffic accidents, airplane accidents. When the NTSB goes in or anybody else goes in to investigate an accident, yes, they interview people and ask them what they saw, but what drives the investigation is what the wreckage tells them, because the wreckage isn't subject to the problems that human beings are in terms of getting the facts right. So any final determination, accident determination of an air crash is fundamentally driven by the wreckage, and often the wreckage completely disagrees with some eyewitness testimony. Completely disagrees. One fabulous example, the crash of the TWA flight off Long Island, took off from JFK Airport and blew up because of fumes in the center fuel tank that were ignited by a wire. Witnesses on the ground that watched that disaster unfold gave wildly erroneous descriptions of what had taken place. And the wreckage did not agree with some of those descriptions at all. They described things that were, they described, instead of things falling from the plane to the ground, they described things moving from the ground to the plane, all sorts of things that were shown not to be true. So, we want to interview people, we want to see what they had to say, but at the end of the day, if it comes down to what a survivor says and what the wreckage says, the story the wreckage tells is not contravened, is incontrovertible in many ways, right? So the Titanic wreckage says a couple things to me. It definitely broke apart predominantly well under the ocean. It broke apart from the bottom up, not the top down. And it broke apart in stages that were related to its drift in the current. These are the things that the evidence on the seafloor says. If you go look at the James Cameron special, and again, I have a lot of respect for James Cameron. If you look at the special, it bends over backwards to try to explain these patterns on the seafloor because of having to assume that the ship was stationary at the time that it came apart, and that it came apart on the surface, and that it broke from the top down, and has to go through all sorts of various phantasmagorical machinations to make the evidence on the seafloor fit those assumptions. But scientists need to, are the people who toss those assumptions to the side and say, if your assumptions are leading to very complicated and in many cases incoherent explanations, we're going to go back to the evidence and we're going to start there and see what it says. Right, let me see if we have some other questions here tonight. What is next with my theory? Well, folks, I think this is the absolute end of the line for me. I have actually been thinking about this for a decade, since I saw that James Cameron special and also read the National Geographic article and looked at that map of the sonar map of the debris field. So I've been thinking about this off and on for a decade from a scientific perspective, but this is not the Titanic is not my thing in that regard. And as I said, there's an entire universe of people who make their living on the Titanic, and there are Titanic fanatics who know everything there is to know about the Titanic. There are people who know who was in every single stateroom, all that kind of stuff. That's not where I came into this. Like many of you, I came into this because I was fascinated by the decision-making that resulted in the accident happening in the first place. But when I saw that special and I saw how science was not being brought to bear and how a theory was being put forward, but immediately one of the most crucial pieces of evidence was just being taken off the table, I was like, I think we can do better than this. And I began thinking about it from a different way from that point forward. Let me see if there's any more questions, and then we will finish. Will I write to James Cameron? I did write to James Cameron. And shockingly enough, James Cameron did not write back to me. It did not surprise me at all. First off, James Cameron receives thousands of letters a year from all sorts of people, and I'm sure he has a lovely assistant who opens them and reads them and occasionally writes back, Mr. Cameron, thanks you for your thoughts. But I did write James Cameron, and I wrote several other people who were involved in the Titanic, the Final Word special. Only one of them ever got back to me briefly. It didn't bother me at all. I completely understood from a variety of fronts, because the Titanic is one of these subjects that if you get involved with the Titanic, you're going to encounter a lot of people who are just so fanatical about it that the best thing to do is just sort of like keep them at bay, because that can be a path down which you do not want to go. Listen, I think that's the last question for tonight. Oh, there's one more. What was damaged first after hitting the iceberg? The iceberg, the Titanic brushed the iceberg on its starboard side, and the evidence was collected from a Discovery Channel expedition in the late 1990s using ultrasound technology. That what happened to the Titanic was that for about 300 feet on the starboard side, the hull plates were separated a little teeny bit, just pushed apart just a little teeny bit. They were not ripped open, they were just separated. The total amount of space that was open to the ocean was about the equivalent of 2 squares of standard city sidewalk, like you might see in a outside someone's house. But through that opening, tons of water began to pour into the Titanic, I think per second. The opening was 40 feet below the waterline. The water pressure at that level is already incredibly high. And there was nothing that could be done to seal those gaps. And for a variety of other design reasons, the Titanic could not deal with 300 feet of opening. But then some other things happened that accelerated the disaster. Passengers left their portholes open. So when the ship started to go down in the water, those open portholes began to let water into the ship. But another thing happened as well is that they opened on the port side the D deck first class entrance door, a huge door on D deck, 4 decks down, because the idea was they were going to bring the lifeboats back and they were going to put more people on the lifeboats, loading them off of the D deck door, because they were having a lot of difficulty lowering the lifeboats when they were full. They had not done any lifeboat drills. In fact, you know, the first person to actually recreate the lowering of a Titanic lifeboat was James Cameron, who did it for his film. And they found out it was incredibly hard to do, especially when fully loaded. And it took a very long period of time. One of the more sobering pieces of information about Titanic, for those of you who are keeping score, it wouldn't have mattered if she had more lifeboats. They didn't have enough time to load the lifeboats they had. The last lifeboat they had was never even loaded. It was washed off of the ship by the ship sinking before anybody could get in it. If they'd had another 16 lifeboats, they would never have loaded them, because they could never have loaded them quickly enough to get people into them. Those boats would have gone down with the Titanic. But they opened the D deck door, and the D deck door, its surface area was about the same as the part of the Titanic that was open to the sea by the iceberg. They were unable to close the D deck door. The ship listed to port at one point a little bit. They were unable to close the door. It went underwater open, and at that point doubled the opening of the ship to the sea, and pretty much condemned Titanic to sinking even quicker than it would have otherwise. So that answers that question for those of you that are new to the disaster. Okay, we've gotten to 8:25. I don't see any other questions. I want to thank all of you for your patience. I'm sorry about the one snafu when I was trying to talk about the ship and I was showing you my whiteboard instead. I apologize for that. I am so grateful that you joined me tonight for this talk. And I hope that what I've offered you has given you at minimum some food for thought about science and the role of science and thinking scientifically, if not about the Titanic itself. The saga of the Titanic will continue. There'll be other theories, there'll be other explorations. I'm hoping what I put out tonight might eventually contribute to that in some way. But whatever the case, it's been a real pleasure to do this. And especially having worked on it and thought about it for a decade, really amazing for me to have this opportunity. I'm extremely grateful to the MIT Club of DC for the opportunity. I thank you all very, very much. And please do consider, as Anne Street mentioned at the beginning, please do consider joining the board of the MIT Club of DC so that you can help us produce other events like this. Thank you so much, and good night.